Hi, today we're going to be talking about Cartesian and polar coordinates. So the question is, what is polar coordinates? Well, let's give a little example here where we have a point in our well-known Cartesian x, y coordinate system, and we have this point 1, 1. In polar, this is described by a radius, r, and an angle, theta. So here, Cartesian xy, you might think xy. In polar, that's r theta. Okay. So we know x is 1 and y is 1. How can we obtain a radius and an angle? Well, we know that this adjacent angle, adjacent length right here, we can make a triangle in the Cartesian coordinate system with an adjacent of 1 and an opposite of 1. So we know that, hey, r squared is equal to x squared plus y squared, which is going to be 1 squared plus 1 squared, and so we get r is equal to the square root of 2. We also know that, hey, if we think about the Cartesian point with an angle, that tangent of theta is going to be y over x, which in this case is 1 over 1, and that implies theta is equal to pi force. So we're able to obtain the r theta point with r being square root of 2 and theta being pi over 4 here. Okay, so that's our polar point, and to summarize, if we want to convert from Cartesian to polar, well, we did that direction. R is equal to the square root of x squared plus y squared. And theta here is this arc tangent of y over x. So you might ask, okay, what if I have a point in polar in which the radius here is 2 and this angle is pi over 3. So the point is 2 comma pi over 3. How do I get then to Cartesian? So going the other way. So I want to describe this in terms of x and y. Well, we need the xy point, and here we're going to think about triangles again. Okay, I know that in the polar land I can make a triangle. And if I make the triangle, then hey, this length is x, that length is y, and sine of theta is going to be opposite, which is y, over r. So that tells us y is equal to r times the sine of theta. Similarly, we have cosine of theta. Remembering our trigonometry is going to be adjacent, which is x over r. So x is equal to r times cosine of theta. Okay, so there we go. That's how we convert from polar to Cartesian. Now let's do it. We know that y is equal to 2 times the sine of pi thirds. Which is going to be root 2. And x is going to be 2 times this cosine of pi over 3. which is 1. So our xy coordinate system is 1 comma root 2. And there we go. That was a brief introduction to polar coordinates.